I will try to highlight some of these key activities, but first let me give you a little bit more information about the importance of the OCO mission. Carbon dioxide is often regarded as the principal human-produced driver of global climate change. Now, since the Industrial Revolution about 200 years ago, atmospheric concentrations of carbon dioxide have actually increased on the order of about 30 to 40%, from 280 parts per million to more than 385 parts per million. Now, it's been estimated that human activities such as the burning of fossil fuels and cement manufacturing have actually produced on the order of 200 billion metric tons of carbon being emitted into the atmosphere. However, scientists can only account for half of that amount remaining in the atmosphere. The other half is actually being absorbed by the land biomass and by the oceans. However, we as scientists still don't know where that's going. Now, there exists a global network of carbon dioxide monitoring stations. However, these monitoring stations are few, far between, and not evenly distributed. It's not only difficult but impossible to determine where these sources and sinks of carbon dioxide are without having a space-based platform. That's one of the key requirements that we have for the Orbiting Carbon Observatory. Now, OCO, or the observatory itself, is comprised of a single instrument. It's a 3-channel grading spectrometer and a dedicated spacecraft bus. Now, you'll see some of the activities here. The team is actually in the process of what we call the unbagging, unwrapping, and cover removal process. The key step that you'll see next in the next several frames here is the lifting of the observatory in preparation for mating with the upper stage components of the launch vehicle. Now, one of these important aspects or significant or special components on the launch vehicle is what's called a soft ride vibration isolation system. You can look at that as a shock absorber, basically, for the observatory. And the next several frames, you'll actually see the observatory being encapsulated by the fairing, 2 fairing halves. And once this assembly is completed, this assembly is referred to as the encapsulated cargo element. Now, we joke around a little bit about this on the project. We refer to this as must be a term of endearment to be referred to as cargo. But as John pointed out earlier, it's being cocooned, the observatory, into this fairing structure. And you can see here that the encapsulated cargo element is being transported from the payload processing facility to Launch Complex 576E. Now, let me go ahead and start talking a little bit about the OCO launch. As mentioned earlier, the OCO launch is scheduled for early tomorrow morning at approximately 1:51 a.m. Pacific Standard Time. Now, the Taurus XL 4-stage launch vehicle will inject the observatory into its proper orbit in just a little over 13 minutes. Now, the OCO flight team is going to be looking for 3 significant events to occur shortly after separation. Number 1, we want to ensure that communications is established between the ground controllers and the observatory. Number 2, we also want to verify that the solar rays have been deployed. And number 3, we want to ensure that the observatory can actually point these solar rays to the sun and charge the batteries. Now, the flight team fully expects these 3 activities to be completed within an hour or an hour and a half after separation. Now, during the first 5.5 weeks of the mission, the flight team is also planning on completing what is called the in-orbit checkout, or IOC phase of the mission. Now, IOC is divided up into 3 distinct subphases. There's a 10-day spacecraft checkout subphase, a 20-day orbit ascent subphase, and finally there's a 7-day instrument checkout subphase. Now, I do want to state that the flight team has every responsibility to ensure the health and the safety of the observatory during IOC, so it might take a little bit longer. Instead of 5.5 weeks, it could take as long as 13 weeks to complete IOC. Now, once IOC is completed, though, we would have verified the health of the observatory, and we also would have configured OCO for routine operations. Now, this includes maneuvering OCO into its proper position as the lead spacecraft in the Earth Observing System's afternoon or A-Train constellation. If I can go ahead and ask for the first graphic, this would be the artist's rendition of the observatory in flight. Thank you. Now, in order for OCO to acquire accurate measurements over both land and water, and to validate the measurements made from space, the observatory will operate in 3 principal modes as it maps the globe every 16 days. These modes are nadir mode, glint mode, and target mode. Now, in nadir mode, the instrument will essentially be pointed downwards as the observatory orbits the globe. Now let's bring up the next graphic. Thank you, glint mode operations. Now to compensate for the fact that reflectivity off of the ocean surface is relatively low, OCO employs what is known as glint mode. So in glint mode, the instrument will actually be focused on a moving spot on the Earth's surface where the sun's reflection is most intense. Now, this glint mode operations actually requires the observatory to perform a slow pirouette in space. However, this mode significantly improves the measurements that are made over Earth's dark ocean surface. Now, the nominal plans call for the observatory to alternate between nadir mode and glint mode operations every 16 days, so that the Earth will be mapped in each mode on roughly monthly timescales. So let's go ahead and bring up the third and final graphic, the target mode graphic, please. Now, in order to validate OCO's space-based measurements, they have obviously had to be compared against similar measurements that are obtained on the ground. Now, in order to do this, OCO employs what is known as target mode to observe surface targets such as the validation site located in Darwin, Australia, or Lauder, New Zealand, or even here, or like here in the United States with Lamont, Oklahoma. Now, this point and stare mode allows a stationary surface target to remain within the instrument's field of view, even as the observatory orbits the globe. Now, by doing this, including in the plan, our science measurement validation plan requires that we look at a certain site at least once a day to make sure that we can acquire validated telemetry. Now, I do want to also state that the OCO science team has made 3 major commitments to the sponsors at NASA headquarters. Number 1 is to publish what we call the initial science data products. These are calibrated spectra of the reflected sunlight, and we need to do that within 6 months after the completion of the in-orbit checkout, or IOC phase of the mission. Number 2, the science team plans on publishing what are called the exploratory science data products. These are the initial estimates of atmospheric carbon dioxide concentrations, and we intend to do that within 9 months after the completion of IOC. And thirdly, we will be publishing the final science data products, and these are the validated estimates of atmospheric carbon dioxide concentrations, and we'll do that within 6 months after the completion of the 2-year mission. Now, in closing, I would like to say that the OCO flight team is ready to complete final launch site processing and prepare for the launch early tomorrow morning at 1:51 a.m. Pacific Standard Time. The team has completed all of its preparations for mission operations. All of us are sincerely excited about not only the launch, but of the important science data return in the months and years to come. Thank you very much. George, back to you.
Thank you, Ralph. And now for a look at the launch weather forecast in the morning. Captain Damon Voorhees, the launch weather officer for tonight's launch from the 30th Weather Squadron here at Vandenberg Air Force Base. Captain Voorhees.
Thank you. Good morning. Tonight, my team and I are going to continuously monitor the weather to ensure a safe launch and flight of the Taurus vehicle and the OCO payload. And it's always especially rewarding for us as a team of meteorologists to aid on a launch of an environmental satellite. Now, each launch from Vandenberg has a set of weather rules or constraints that we must adhere to, and that's what we're going to monitor tonight. And that's to ensure that the vehicle is protected from both natural and triggered lightning here on the coast of California. In addition, tonight, there's also going to be a set of wind rules that we're going to have to monitor, and that's going to protect the vehicle from tipping over or blowing off course on its way up. And should we be outside the limits on any of those rules, Orbital or the 30th Space Wing will hold or scrub the launch. And that's to protect the rocket and the safety of the local population. And I believe we have some satellite imagery from this morning. Kind of a gloomy start here. We've seen off and on rain showers so far today and a lot of cloud cover. The good news is that it is going to clear throughout the day. And by the time we get to this afternoon and this evening, should see mostly clear skies. Just a few high and low clouds lingering into the launch window. But all in all, expected to be pretty favorable weather for the launch. And the official forecast at T0 calls for scattered stratocumulus clouds from about 2,500 to 5,000 feet and some high cirrus clouds above that. The winds will be light out of the northwest at about 8 to 12 knots. Temperature in the upper 40s, maybe some light fog, reducing the visibility down to about 5 miles. And upper level winds in the jet stream will be about 75 to 80 knots at about 40,000 feet. Again, that is favorable weather for the launch, and the probability of violating one of the launch rules tonight looks like it's going to be about 0%. And if we should have to make a second attempt tomorrow night, the weather continues to improve through the day into tomorrow night, and probability of violation tomorrow night would be 0% as well, with